29. Again, we could approach this. You could try to do like an inverse cosine and find out all the solutions. Again, we're going from 0 to 2 pi. The graphing calculator does give us a very straightforward way. We just put in cosine of 4x. And we want it to be equal to 1/2, so we're going to look for where does it intersect 1 divided by 2. We're going to go to the graph, so again we'll do, notice our window set from 0 to 360. What needs to be important is we need to be in degree mode, not radian mode. It's different, so the inputs are going to be degrees. Yes, they do want the answers in radians, but we are going to convert, and it's a lot easier to convert from degrees to radians than decimals to radians. So we look at our window going from 0 to 360, 0 to 2 pi. The x scale is, so there'll be a tick mark every 90 degrees. And since we want to intersect at 1/2, it's fine that we're going from -1 to 1. Okay, because we'll see it. And then we go to the graph. There's the cosine of 4x, and there's 1/2, and we're going to have 1, 2, 3, 4, 5, 6, 7, 8 answers. So we're going to be a little busy in converting, but second calc we find the intersection, and I'm going to ask for the first curve. It's on there. I'll hit enter. Second curve is the 1/2 part. Yes, that's where we want to be. And then let's start, kind of do it in order. Let's get close to this one. We'll put enter. It finds the intersection is at 15 degrees. So one answer for x, for theta, is 15 degrees. Again, I can't put that in as my answer. I'm going to have to do radians. So again, each time it's 15 pi over 180, because the conversion factor is pi over 180. So we multiply 15 times pi over 180. That will cancel out the degrees and give us our final answer. 15 goes into 180, I think. 12 times. So 15 divided by 15 is 1 pi. 180 divided by 15. Again, just getting in reduced mode is 12. And then we're going to find the next one. Second calc. Find the intersection, number 5. Enter, enter, and then we just walk the little spider guy next to the next one, hit enter, and we get our next intersection at 75. Let's just keep doing this. We'll get the next one, second calc, number 5, enter, enter, walk over, and say enter on this one. That's our guess, so we'll get the intersection at 105. Go to the next one, second calc, number 5, intersect. Well, that's why you do enter, enter first. I'll do enter, enter. Now that I'm on this tightrope walk, I just walk over to the next intersection. There it is. Enter. Close enough anyway. 165. And then second calc, number 5, intersect. Enter, enter. Go there. Enter. 195. Second calc, number 5, enter, enter. Let's go to the next intersection place over here, close enough. Hit enter, the guess it's 225. Wouldn't it be nice if they just let us put it in terms of degrees? We'd be done right now, but we still have to go through and convert all of these to radians. Enter, enter, come over here, because that's the, yeah, they ask you for a first curve, second curve, and then a guess. So 285 is another intersection. And then the last one, second calc. Number 5, intersect, enter, enter. There we are, 345. Again, we want to, so our answer up here, I'll put that up here, is going to be pi over 12. The next one's 75 pi over 180. Pi over 180 is our conversion factor, right? Because that's at pi 180, that's in a place where they're equal. And then we just reduce it. Let's see. 15 goes into both. I think we could do just about all of these by 15. So yeah, 75 divided by 15. Is 5. So the top becomes 5 pi. What was that? It's a weird looking pi. 5 pi, and then 18 divided by 15 is going to be 12. So you'll see, I think, you know, you're probably all going to be pi some kind of a 12. But let's see how that works out. And we know that 180 divided by 15 is 12, so we're just, so 105 pi over 180, let's just try it. Let's divide both by 15. Does 15 go in evenly? Probably. 105, I guess I could do it here, divided by 15, that's 7, so that's 7 pi, and then we know 180 divided by 15 is 12, so that's the next one. I'm just going to do this again and again, so let's see, we've got those. 165, and again, let's just guess, I think it's 15, I know it works with the 180, let's see if it works with 165. 165 divided by 15, is that a whole number? It is. It's 11 pi over 12. So there's another one there. Yeah, okay, be that way. I don't want it there, I want it over here. I just love how technology obeys everything we tell it to do. No, it doesn't. But that's okay. We just let it go. Just let it happen. Now 195, and let's try 15 should go into both. So 195 divided by 15. Let's see what we get. We get 13. So we get 13 pi over 12. Again, if you yours might be a little different, so you know, but the process will work the same. Okay. 225 pi over 180. You know, let's try it again. It's just a matter of kind of multiplication facts, simplifying fractions. 225 divided by 15. But once you get into some of these patterns are kind of nice. Okay, 15 pi over 12. And you can see maybe why some people get to liking math. Now, it's not always the real world doesn't give us these nice numbers, but oftentimes we get it in the math theory parts. So let's try this out. 285 divided by 15, that's a 19, so 19 pi over 12. It's a lot of these. But just use the technology, and then 345. Over 180, and let's see, 345 divided by 15 is 23. 23 pi. Oh. always thought, what if I just let myself go and just start writing random things? Would it really maybe it would make sense? Maybe I'd discover some undiscovered thing. Or maybe it would just be strange writings, who knows? Anyway, there we go. 1, 2, 3, 4, 5, 6, 7, 8 answers. That's what we put in for this one. And again, yours may be different, but just set, put y1 here, y2 here, and then find the intersections and make sure you're in degree mode, because then that just makes it easier for the translation. Otherwise you get a bunch of decimals, and what it's going to want is this pi over 12 is what's this. You could probably get it from decimals as well, but it's a little more complicated, I think. Anyway, take care.